Welcome to CARICOMP Insider, where high-tech facial recognition meets real-world intelligence.
More than half the time, you can't tell a deepfake from a real video. According to recent research published in scientific reports, about 53.5% of people are fooled by digitally altered media. That means your eyes perform barely better than a coin flip. That number should sit with you for a second, because it changes everything about how we think about manipulated video. If you've ever watched a clip someone sent you and thought, "That looks legit," you are making a judgment your brain isn't equipped to make reliably. And if you're someone whose job depends on telling real from fake, an investigator, a journalist, an analyst, that coin flip accuracy isn't just uncomfortable. It's dangerous. If that feels unsettling, it should. But understanding why your eyes fail is exactly how you stop feeling powerless. So why can't we see the fakes anymore? And what actually catches them? Most people believe they can spot a deepfake by looking for glitchy eyes, weird blinking, or lips that don't quite sync with the audio. That belief isn't irrational. A few years ago, early deepfakes did have visible flaws. Strange eye movements, skin that looked waxy, mouths slightly out of rhythm. People spotted those tells and anchored to them. The problem is that modern deepfakes have eliminated almost every one of those visual cues. Today's manipulated videos replicate facial expressions, speech timing, and emotional micromovements with startling fidelity. They blend skin transitions and hold consistent lighting across frames. According to MIT researchers, there's no single telltale sign you can rely on to catch a fake with your eyes alone. So the confidence people carry from spotting one bad deepfake in 2020 actually makes them worse at evaluating today's fakes. They think, "I caught that one, so I'll catch the next one." They won't. So if human vision can't do it, what can? Modern detection tools work by reading signals your eyes were never designed to see. They combine two layers of analysis. The first is the spatial domain. That's the RGB pixel information, the actual colors and shapes in each frame. The second is the frequency domain, which uses something called a discrete cosine transform, basically a mathematical way of breaking an image into patterns of light and dark that reveal hidden inconsistencies. Neither layer works well alone. Detection systems that rely on only one of those signal types fail under real-world conditions. The systems that actually hold up fuse both layers into a hybrid approach. For anyone who's ever adjusted the equalizer on a stereo, boosting bass, cutting treble, frequency domain analysis does something similar with an image. It isolates bands of visual information that the naked eye blends together. That's where the manipulation fingerprints hide. But even those hybrid tools have a serious weakness, and it's one most people never think about. Compression. Every time a video gets uploaded to a social platform, it's recompressed. That compression changes the texture, drops the resolution, and shifts the color depth. The pixel-level traces that detection algorithms depend on get smeared or erased entirely. A video reposted 3 times has been recompressed 3 times. Each pass strips away more of the evidence. For an investigator, that means the screenshot pulled from a group chat may have already lost the signals a detection tool needs. For the rest of us, it means that viral clip you're watching has probably been laundered through enough compression cycles to wash it clean of detectable manipulation. Systems trained on high-quality, pristine video perform poorly when you hand them a blurry, cropped, heavily compressed clip from the real world. The article's own analogy captures this perfectly. Deepfake detection is like forensic DNA analysis. Finding the biological evidence requires knowing what you're looking for and what condition the sample is in. A blood sample shipped in water degrades. A detection model trained only on pristine lab data fails on field evidence. You need to understand the contamination history before you trust the result. And there's one more problem that might be the most important of all. It's called cross-dataset generalization, and in plain terms, it means a tool trained to catch one type of fake often can't catch a different type. According to research from Facebook's Deepfake Detection Challenge, which drew 2,200 competing teams, this problem remains officially unsolved. A detection method that hits 94% accuracy on one deepfake technique can plummet to around 64% when it encounters a manipulation method it wasn't trained on. That's a 30-point drop. Even within known techniques, performance varies sharply. Face swap methods reach about 94% detection accuracy. But subtler manipulations, methods that alter neural textures or blend facial boundaries more carefully, sit down around 80 to 82%, even under favorable test conditions. No single tool catches every manipulation type equally. For professionals building a case, that means a 95% confidence score from a detection tool is only meaningful if you know three things. Was the tool trained on the specific manipulation method in your evidence? What's the compression quality of your source material? And did that tool prove it works across different datasets, not just the one it was built on? Without those answers, a high confidence score is a false sense of security. For anyone watching a suspicious video at home, the same logic applies. The app that says this is real might simply have never seen this kind of fake before. The mistake isn't trusting your eyes. The mistake is trusting any single source of certainty. Your vision, one tool, one confidence score, in a domain where the fakes are designed to defeat exactly that kind of trust. Your eyes catch deepfakes about as well as a coin toss. Detection tools only work when they've been trained on the right kind of fake and given video that hasn't been compressed into oblivion. A confidence score without context is just a number. Whether you're reviewing evidence for a case or just deciding whether to believe a video in your feed, the question isn't, does it look real? The question is, what's the history of this file, and what tool actually tested it? Knowing that won't make the fakes go away, but it turns a guessing game into something you can reason through. The full story's in the description if you want the deep dive.
Now you know something most people in this industry don't. Use it. And when you're ready to put it to work, caracomp.com. We'll see you tomorrow.